So to find the rotational symmetry of any shape, all you'd have to do is do the 360 divided by the lines of symmetry, the number of lines of symmetry. This is what that is. Okay, so for example, looking at this question, which of the following transformations carry this regular, so again, regular meaning all the sides and angles are the same, onto itself. So in terms of reflection wise, you can see that if you put a line of reflection right here and you fold this right here, you see that this is going to come to that side. So this has a reflection line of symmetry, so across L. But does it have any rotational symmetry? So to find rotational symmetry, all you need to do is do the 360 divided by the number of sides, but only if it is a regular shape. So because they've told us that it is regular, so we can do that. So you need to find out how many sides there are. So you put your pen on one side of it and you count 1, 2, 3, 4, 5, 6, and I'm back to my starting point. So this has 6 sides. So to find the rotational symmetry, all you would need to do is do 360 divided by the 6 sides, which is 60. So every time you turn this 60 degrees, it will look exactly the same. So if you turn this 60 degrees left counterclockwise or 60 degrees right, doesn't matter, it's going to look the same. Okay. All right, so which following transformations carry this regular polygon unto itself? So same idea, same thing. If I put a line right here and I fold this triangle, is it going to fold right into this? No. So it does not have a reflectional symmetry at this line. But let's check if it has a rotational symmetry. Now, because again it says regular, it means all the sides are equal. How many sides does this have? It has 3. And it's always going to be 360 divided by the number of lines of symmetry. And because it's a regular shape, the lines of symmetry is the number of sides. So this one has 3. So you do 360 divided by 3, which is 120, which means every time you turn this 120 degrees, it looks exactly the same. So if I turn it 120 degrees to the right, it's going to look the same, not 60 and not 45. So any multiple of 120. So if I turn it 120, or if I turned it 240, or if I turned it 360, it will look the same. So there are 3 times that this is going to look the same. All right, which of the following transformations carry this regular? Again, regular means all the sides and angles are exactly the same. So how many sides does it have? So put a starting point and count. 1, 2, 3, 4, 5. I'm back to my starting point. So this is 5. So it has a rotational symmetry of divided by 5, 72. Every time that it's 72 degrees, it will look the same. So 72 degrees, it will look the same in any multiple of 72. So 72 plus another 72. At 144, it will look the same. Plus another 72. At 216, it will look the same. At 288, it will look the same. If you just keep adding 72, at 360, it will look the same. So these are all the different angles that I can turn it, and it will look exactly the same. All right, which of the following transformations carry this regular polygon onto itself? So same thing, so let's look at this line. If I fold the right-hand side to the left, is it going to fold into place? No. So this is not a reflection of this side. So it's not reflection. All right, rotational-wise, rotational symmetry again, if it's a regular polygon, which means all the sides and all the angles are equal, then the lines of symmetry is the number of sides, because remember the formula is 360 divided by the number of lines of symmetry. So this is 4, so you do 360 divided by 4, be 90, which means every time you turn this shape 90 degrees, it's going to look exactly the same. So every time you turn it 90 degrees, and any multiple of 90, which means 90 plus another 90, if you turn it 180, it will look the same, plus another 90, plus another 90. So 270, 180, and 360 will also look the same. But they don't give you all those options, so you just click the ones that are given to you. Which of the following transformations carry this regular polygon onto itself? So let's look at this line again. If I take this side and fold it, does it fold into place? No, it does not. So it's not a reflection. And because it's a regular polygon, the number of lines of symmetry is the exact number of sides the shape has. So let's count how many sides it has. 1, 2, 3, 4, 5, 6. It has 6 sides, which means it has 6 lines of symmetry, only because it's regular. If it wasn't regular, you'd actually have to draw in how many lines of symmetry it has in order to know. All right, so again, you go 360 divided by 6, and that's going to give me 60. And any multiple of 60, well, the next number will be 120, so that's not any of those. All right, so again, a regular polygon, which means you just count the number of sides. You don't have to actually draw the lines in. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Back to my starting point, so 9 points. So you go 360 divided by 9 is 40. So every multiple of 40, whether you're going left, right, doesn't matter. So 40. And then the next one will be 80. The next one will be 120, which is bigger than all those numbers. So I don't have to keep checking. All right, again, let's fold along this line. If I fold it, is it an exact replica? Yes, it is. So it's a reflection right across the line. And now we're going to check rotational symmetry. And all you have to do, again, because it's regular, is all the sides are equal. Therefore, the number of sides is the number of lines of symmetry. You don't actually have to draw it. So all you have to do is count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one has 10. So do 360 divided by 10. It's going to be every 36 degrees it looks the same. So every 36 degrees. So I don't see 36 there, but because I see numbers bigger than 36, I'm going to check for the next one. So it also at 72 degrees it'll look the same, plus another 36. At 108 degrees it'll look the same, plus another 36. At 144 degrees it will look the same, and I've passed all these numbers without hitting any of those. So that would be my final answer. All right, same thing. I think all of them will be regular, so I'm not going to keep saying the exact same thing. So look at this line. Can it fold into shape? Nope. It's regular, therefore the lines of symmetry are the number of sides, which is 3. So 360 divided by 3 is 120. Oops. And any multiples of 120, well, the next one would be numbers bigger than this, so that's okay. All right, so let's take a look at... All right, this line right here, if I fold it, would it fold into place? Yes, it would. So L2 definitely. What about L1? If I fold it this way, yes, it would. So L1 for sure. And then let's check rotational symmetry. Starting here, 1, 2, 3, 4, 5, 6, 7, 8. So 8, so 360 divided by 8, which is multiples of 45. So 45 degrees to the right or to the left, it'll all work. All right, isosceles trapezoid. Okay, now see, it does not say that this is a regular. Oh, this is good. It doesn't say that's regular. So let's do the line symmetry first. If it folds, does it fold into place? Yes. So across that line, yes. Now, because it doesn't say it's regular, I can't count 4 sides and say, oh, it's 360 divided by 4, because this is not regular. These are not all the same. They're all different. So with this one, you actually have to figure out, if I turn this shape any kind of way, is there any other angle that it will look like this? So let's say that I try to turn it 90 degrees, or really even if I start turning it. So remember, it just looks upside down with the top being the longest, okay? So does it look the same? No, 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 no. Doesn't look the same, doesn't look the same. This kind of looks similar, but it's not quite, because this top needed to be longer and then short on the bottom. So that's not, 180 doesn't work. And you just keep turning it, turning it, turning it, turning it, turning it. And it looks like there's nowhere where this shape looks exactly like this, except here at 0 and 360. And since none of those are the options, submit. All right, so let's do the blue line of symmetry right there. If I fold it, is it going to fold in place? No. Let's do the purple line. If I fold it here, is it going to fold in place? No. It is a regular polygon, which means the number of lines of symmetry is the same as the number of sides, which is 4. So if you do 360 divided by 4, you'll get a rotational symmetry of 90 degrees, meaning every time you turn it, 90 degrees is going to look the same. So whether you're going left or you're going right, doesn't matter. Which of the following transformations carry? Okay, again, same thing. So if I fold it, is it going to fold into place? Yes, it is. And then rotational symmetry. Now, does it tell us that it's regular? No, because it's a rectangle, which means all the sides are not the same. So this one, you actually have to do it. So now remember, But let's say these are the two shorter sides and these are the longer sides, right? So if I turn it, do you see the two longer sides on the top? Nope, I don't. Nope, I don't. No, I don't. And this is 180 degrees. Now this kind of looks similar, but it's not because this is short, right? I needed it to be the two longer sides on the top and the two shorter, so that's not working. If I keep turning it, too long on the top, too long, yes, right here. So this works because I've got the too long on the top and too short on the side. Now I have to figure out how much did I turn it. Okay, so this is what I started with. This one turn is 90 degrees. Two turns is 180 degrees. So if I turn this shape 180 degrees, it looks exactly the same. So 180 degrees works. If I keep turning it, keep turning it, keep turning it, the only time it looks exactly the same is when we're back at 360. So only 0, 180, and 360 would work. All right, which of the following again? So if I fold it, would it fold into shape? No, because you can see this side is like thinner than that side. So no, it does not work there. Because it's regular, I just count how many lines of symmetry by the number of sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a nonagon. So 360 divided by 9 is 40. So every time it turns 40 degrees, it looks the same. So every time it turns 40 degrees in multiples of 40 degrees. Next one will be 80, and that's bigger than all of these numbers, so that would be it. All right, same thing here, regular. Regular means that they're all the same, right? So you could just do 360 divided by the number of sides, which is 4. All right, so 360 divided by 4, which is 90. So it's multiples of 90. So 90, it'll work, whether it's going right or left. And the next one after 90 would be when you add another 90, would be 180, and that's not there, so that's it. All right, we'll do just one more, regular polygon unto itself. So again, regular, just count the number of sides. That will be the same number of lines of symmetry. 1, 2, 3, 4, 5, 6. So it's a hexagon. So 360 divided by 6 will be multiples of 60. So 60 will work, left or right. The next number that after 60 would be 120, and that's too big. And that's pretty much all you do over and over. Okay.